Okay, now I want to talk to you a little bit about rocks. Now, like all the other subjects, I want you to understand the classification, some of the names, and some of the types, so you can be thinking about the composition of these rocks. This week, when we're doing our environments, we're pushing a little bit more stylized than trying to go realistic. But when you want to do something stylized, you're always drawing inspiration from what's really there. So knowing what rocks are made of and what goes into them is really important. So when it comes down to rocks, we've got three major types. And again, apologies to any true geologists out here. This is an extremely simplified version of a very, very deep subject that people spend their whole lifetime studying and never even really get everything done into it. But we have igneous, metamorphic, and sedimentary. Igneous, usually created by some sort of magma or heat reaction. Sedimentary, which is layers of silt, sediment, and minerals packing together and under heavy compression, turning them to rock. And metamorphic, which is a change, usually a combination of pressure, heat, magma, all of these things together, forming very dense and heavy rocks. And then those things are made up of minerals. And that's what I want to talk about first, is that rocks are minerals. So we have these classes of rocks like granite and sandstone here, but those objects are just made up of lots and lots of smaller minerals, which are themselves made up of lots and lots of different elements. And so things like quartz are common in lots of rocks. So if you've ever picked up like a stone or something, you know, some parts of it are sparkly. There's little bits or flecks of things like quartz, which will have a little reflective surface on the, giving it sort of a speckled appearance to it. That's why rocks have all these little dotty details through it, because they're actually made up of lots and lots of different packed together minerals. And there's tons of minerals. In fact, there's some 2,000 of them, and more than half of them are rare. A few minerals tend to make up most objects, but they are, like I said, there's certainly a lot of them, and we're definitely not diving into it. What I want you to understand is, like, they're so colorful, and look at how many of them are. If you pick up a piece of granite and you look at it really closely, it looks from a distance, the granite will look like an overall gray rock. But when you get closer to it, you see that it's made up of lots and lots of colors. The same way that static on a TV looks gray from a distance, and you get closer, you can see its individual black and white dots. Minerals are a similar thing. So these rocks are made up of lots of little different and often very colorful speckles. The Earth itself is made of lots and lots of rocks, unless we're talking about moon rocks or rocks from meteorites. We can assume every rock you're going to run into on this planet came from Earth itself. And there's a lot of different layers to this. So our Earth's crust has its solid inner core, which is just a giant hunk of extremely dense metals that keep at the core of anything. And it is actually the majority of mass of our planet. As we go higher and higher up, we start getting to the mantle, the sort of rock layer that we're most used to seeing. And this is where, like when I talked about terrain, we see tectonic plates shift and start to form mountain ranges and things like that. So the rocks that we see have been uplifted in some way into our surface, but way down under it, it's just like all rock. Even though the Earth is covered, the majority, some 2/3 of the surface of Earth is covered in water. The amount of water relative to the amount of rock is not even close. There's so much more rock on Earth. So first, let's talk about the igneous rock. This is some form of magma, which is like a superheated rock formula. So that's what lava or magma is. That is eventually cooled and turned into a solid rock form. These, let's see, I'm going to arrange these because I can't see all. So you see from the diagram here, I think I used this before when we were talking about lava as well, or not lava, we're talking about volcanic uplift. We get this idea that they get pushed out of a magma chamber from someplace deep in the Earth, and then they cool when they hit the atmosphere. So this is different depending on where it is and the minerals used and how quickly it cooled that can form into different kinds of rocks. And it goes from everything like this incredibly shiny, dark onyx sort of glass is called volcanic glass. That's actually what dragon glass from Game of Thrones is based off of. That gets really sharp and extremely shiny, to something like this pumice stone, which is formed sometimes out of the same exact volcanic eruptions, which is instead very matte and very porous and very round overall in shape. So it's produced by these extremely dense magma chambers, pushing that magma out, and as it cools, it will gradually form into the rocks that you see here. Sedimentary rock is the accumulation of lots of particles over time. This is why sedimentary rock, you tend to see like it has real layers to it, because it's just layer after layer of like sand and minerals and silt and sediment packed up. This is also where you tend to find fossils, tend to be in sedimentary rock, because something got stuck in there or the bones were buried and it just gradually over time pressed further and further down. It has a lot of very strong, very distinct striations, and its color is primarily based on its iron composition. So these kinds of rocks can be greenish or gray, or can be reddish or brown, depending on how much iron is in there. So the more iron, the tends to go more red-brown in its overall coloration. And it usually has as its base either quartz or calcite. So it has that, again, if you've ever seen like a sandstone, there's actually a sparkliness to it as you turn it over and you look at it, it's the quartz or calcite in it. So this is also, as I said, where we tend to find things like fossils. But this is formed from the oceans or bodies of water moving these things and then over time packing them further and further down. And although it makes up a very small percentage of the Earth's crust, only about 8%, it is overall 73% of the Earth's surface. Because this is the interaction of water and silt, this is not as much on the top layer. This is on the top layer of the Earth a lot, but if you dig down deeper, you're not as likely to find this kind of sedimentary rock. So this is more surface level of the Earth kind of thing. And then we have metamorphic rock. This is generally like existing rocks, sedimentary or magma rocks, are formed and pressed under high heat and pressure. So metamorphic, meaning metamorphosis, it transforms from one rock into another. So this is, as opposed to sedimentary, it doesn't make up a lot of the surface of the Earth, only about 12%. So there are certainly places and you can find metamorphic rock up above the surface of the Earth, but it's actually much less common than sedimentary rock up on the surface. However, it makes up an overwhelming majority of the Earth's overall mass, because this is all that stuff that is through heat and pressure is condensed down into things. And this is a lot of the rocks you might be familiar with, things like slate or gneiss or marble even, and quartzite, which is a rock formed of lots and lots of quartz. So this is, unlike sediment, there can be striations and patterns in it, but it has often like these interesting swirly patterns, like marble is like that, because it's the result of pressure and heat as opposed to layers and then gravity pushing it down. Rocks, of course, come in lots of shapes and sizes. The official classification go from granules, which are just 2 millimeters, up to boulders, which are, a couple of meters in height. And so this is like, they not only have like different sizes depending on their makeup. So like a sandstone, for instance, can't necessarily have the same sharpness or shape because it's sedimentary rock and it tends to erode much more quickly. And you see this in different shapes depending on their environmental factors. So these are examples of some stones that are more like smaller in size. These stones tend to become softer over time, especially as they get worn over with water and sand. So if you go on a beach, you'll notice lots of very smooth, round rocks on a beach because they have been pushed around by the ocean and they keep rubbing up against the sand, getting to a point where it becomes a very rounded shape. Then we look over here at these little cliff faces, which are clearly a channel where water erosion happens, and we can see that as water would rise and tide comes in and pushes across, it cuts these grooves into the sides. So it might take existing striations of sedimentary rock and exaggerate them by wearing away the weaker minerals along certain layers. So you see some of these layers are eroded and some of them aren't as much, and it's because you have compression and some of that compression is tighter and stronger. The water's going to go through the weakest spot and take the weakest minerals from that rock away. And all rocks can also be very sharp, and this is sort of a good example of some metamorphic rock that is cracking and pushed up. So this is most likely pushed from some sort of uplift, and it created this sort of shattering effect. And remember, just like we talk about these sizes, small rocks come from larger rocks, and even these boulders come from larger still rocks. Rocks are strong and they're tough, but they're also brittle, which means they can crack, they can separate, they can split, and they turn naturally into smaller and smaller pieces of ourselves. Remember, like we talked about with terrain, gravity and erosion means everything wants to come down. Everything eventually wants to pull apart. And so we'd always look for those weakest spots. So this is just a brief introduction to a very fascinating topic, and I just want you to be thinking about and looking around. When you take a walk today, pick up a rock you see, look at it. What is it made up of? What are the details? And ask yourself, how did it get there? And maybe what was it formed out of? All right, I'll see you in the next one.